Hello everyone. So now let us start with the problems on slope deflection method. So we have already studied what is slope deflection and what are the equations of slope deflection. So let us quickly just see what is slope deflection equation. So slope deflection equation between any two given points is given by, so moment, if you want to find moment from A to B, it is nothing but Mfab, that is moment, it is which is fixed at A and B, fixed at A and B is the second point, plus 2EI by L, then in the bracket 2 times theta A. So A is the first joint, so always the first joint will multiply with 2 times. So 2 times theta A plus theta B minus 3 delta by L square. So wherein Mfab is the moment at the fixed end, that is at A. EI is the modulus of rigidity. L is the given length of the between the two spans, and A is theta A. Theta A is the rotation at end A. Theta B is rotation at end B, and delta is nothing but it is a settlement or sinking of the support. Okay, all right. So with this, let us start with the first problem. So in the given problem, they've asked to analyze the two span continuous beam shown in figure below by slope deflection method and draw bending moment, shear force and elastic curve of the beam. So this is the given problem. So it is A, B and C. So it is a double span beam wherein end A is fixed, end C is fixed, and at end and at B joint we have a roller support. Okay, so this is a continuous beam. Now why it is called continuous beam is because continuous beam as well as indeterminate beam. So it is indeterminate beam because you can see here a fixed end has three reactions, that is horizontal movement is restricted, vertical movement is restricted, and in addition to this there is a vertical movement restriction. Okay, so the number of reaction at joint A is 3. Likewise, number of reaction at joint C is also 3. And at B, it is a roller support, reaction is 1. So totally in this beam, we have 3 plus 3, 6 plus 1. So there are 7 unknowns. So unknowns are 7, but equilibrium equations are only 3. That is summation H is equal to 0, summation V is equal to 0, and moment about any given point is 0. So here unknowns are 7, equilibrium equations are 3. So that's why the unknowns are still more. So we cannot uh, solve this given unknowns. So to find the given unknowns, we'll be using a method called as slope deflection method. So again, slope deflection method is applicable for indeterminate structures. Okay. All right. So again, all the steps are same. Okay. So first step is finding the fixed end moments. Okay. So fixed end moments. That's why we are going to add a suffix for that. So moment is nothing but M F A B. So F indicates fixed end moments. Okay. So all the problems in this unit, what we'll be doing here is we'll be splitting the spans. So we'll be treating AB span as one span and BC span as another span. So we'll be splitting the spans and finding out the moments individually. Okay, so the first step is fixed end moments. So to find this fixed end moments, it is MFAB. So it's always start from this end, from left end. So first is MF A to B, and second is MF B to A. So again, moment from A to B will not be same from B to A. So we'll be calculating it separately. So we'll be calculating MFAB and MFBA. Okay. So the first case is I'm finding MFAB. So you can see here MFAB. Again, in AB span, it is having only I. Okay, you can see here. And in BC span, this is 2I. Okay, moment of inertia in AB span is I, and BC it is 2 times I. Okay, and AB is loaded with a point load, whereas BC is loaded with a UDL. Okay, so we'll study this individually. We'll split this and find the fixed end moments. So as we have studied earlier, so AB is a fixed end. Okay, now when we split this, so AB and BC, when we split this end will be treated as a fixed support only. Okay, it will be treated as fixed support. So it is now fixed support with a point load at the center. So if you want to find the fixed end moment for this, so we have already studied when you find fixed end moment. So it is the first case now. So it is a beam which is fixed at both the ends, and there is a simply support, it's a point load acting exactly at the center. Okay, so obviously the fixed end moments would have the formula WL by 8, and here also WL by 8. So that is what we are using here. So it's a fixed end. AB is A to B. We are treating B also as fixed end because we are splitting it. And then we are using the formula, that is, again, it is a point load acting at the center. And that's why MFAB, MFA to B. Okay, so MFA to B, it is minus WL by 8. Okay, so minus is nothing but, see, 40 kilonewton load is trying to push the beam downward. To stop this, there is a moment created because of this fixed support which tries to push it back upward. So in the process to push it back upward, it will go anti-clockwise direction. Okay, so here we have already showed the anti-clockwise direction, but we have to show the signs here. We have to use a sign here. So it is because it is anti-clockwise, so we'll be using negative sign. That's why always the first point when it starts like this, the first point when you move from left to right, okay, the first moment would always be negative because it has to create a negative, that is anti-clockwise moment. So it's always now minus WL by 8. So the same W, 40 into L, 4 divided by total 40. This is 40 into only length of AB. We are interested only in AB now. So AB is 4. Okay, divided by 8. Okay, so it is MFAB is equal to minus 20 kilonewton meter. Likewise, now MFBA. Okay, so we have done with A to B. Next, the same thing, we'll check from B to A. Again, it is a simple, it's a fixed support. Both the ends are fixed and it is a point load. The formula would remain same, that is WL by 8. But this time, the moment would be clockwise. Now, because it is clockwise, it would have a positive moment here. So it is now WL by 8. Okay, so this is, when you solve this, it is again 40 into 4 divided by 8. So it is 20 kilonewton meter. So only thing you should be careful that you should not forget the sign. So always the first point from left to right would be minus, right to left would be plus, clockwise and anti-clockwise. Similarly, we have to calculate the next span, that is BC span. So again, now in BC span, again it's a UDL. Again, B will be treated like a fixed support. So from B to C, so MFBC, now MFBC is equal to minus, again go back to this point. Okay, so you can see it's a fixed support, both the ends are fixed and there is a UDL. In this case, it is nothing but, so again left side, so this is anti-clockwise movement, so minus, it is WL square by 12. This also is WL square by 12. Okay, so we'll be using the same thing, BC. So MFBC is equal to WL square. So it is 20 into 6 square divided by 12. Okay, you should not forget to take the minus sign. Again, minus sign from B to C, because again, same thing. 20 kilonewtons trying to push this beam downward. To stop this, what this B does is it tries to push it back upward. So in the process to push it back upward, it creates a negative rotation. So negative moment. So negative moment means minus sign. So minus WL square by 12. So substitute the value. So W is 20 into length, only BC span, length is 6 square divided by 12. So it is minus 60. Similarly, here also it is MFBC. So MFCB now. Okay. So this is, I've written here MFBC, but this is MFCB. So B to C is minus 60. C to B is plus 60. Okay. The next step is finding the slope deflection, writing the slope deflection equation. So slope deflection equation is given by, okay, as usual, again, we'll again start from MAB, then BA. Similarly, in the next span, MFBC, then CB. Okay. All right. So, as usual, first A to B. So, we are developing four slope deflection equations. That is A to B, one moment. That is MAB. Next is MBA. Similarly, in the next span, MBC. Second one is CB. Okay. All right. So, now we'll start with the first slope deflection equation, that is MAB, so only in span AB. So first we'll write the formula. To make things simple, first write the formula, and next is just the substitution. Okay, now you can see here MAB. Okay, MAB is nothing but it is MFAB. Okay, MFAB. You can write this formula however you want, either MFAB first or this first. So MAB is equal to 2EI by L. Okay, 2EI by L. Okay, now because A is the first term here, because you're measuring, the start point is A here. Okay, AB. So because it's a start point, so it is always a start joint would have, you should multiply 2 times. Okay, so 2 into theta A plus next joint is theta B. So it is only 1 theta B minus 3 delta by L plus MFAB. This is the same formula which we have written here. You can see here, same formula. MFAB plus 2EI by L, 2 times theta A plus theta B minus 3 delta L square. Okay, the same thing we have written here. Okay, next is the substitution. Okay, so 2EI. So in AB span, I is only I. Okay, so we'll write it 2EI by L. So length of AB is 4. So we'll write the length L, okay, as 4. Next, now theta A. So theta A is a fixed support. So because it is a fixed support, there is absolutely no chance of rotation. So we know that always fixed support, the rotation is 0 and even the movement is 0. Okay, movement, rotation as well as the displacement is 0 here. Okay, so now because it is a fixed support, fixed end, so rotation at this would be 0. Then theta B is just a roller support, simply support, so we'll write only theta B. Okay, now this 3 delta by L, now what exactly this 3 delta by L indicates is, delta is a settlement. Okay, settlement is sinking of the support. So in the given problem, nowhere in the question they have mentioned that any support is sinking. It could be either A, B or C. Okay, here they have not at all mentioned that the supports are sinking. So with this data, what we can do here is no support is sinking, that is there is no settlement. So straight away this terms becomes 0. Okay, so only in the given question, if they have mentioned specifically that the supports are sinking, that time you have to measure this. So as of now it is simple, there are no sinking of support, no settlement, so delta is 0. Next, plus MFAB. Okay, now MAB and MFAB, there's a lot of difference between MAB and MFAB. So MAB is a moment about AB, complete, but this is MFAB is the fixed end moment, only in A, from start A to B. Okay, so this will occur only at the fixed support, fixed end. Okay, so we have already found out this MFAB. So MFAB is, okay, MFAB, you can see here, MFAB is minus 20. So you should always consider the sign also. So I'll substitute MFAB as minus 20. So as usual, next multiply this. So this would be, when you multiply this, 2 by 4, this would be half, okay, half theta B, multiply this theta B, EI theta B. So it is half EI theta B minus, okay, both the terms are 0 only here, okay, so minus 20. So MAB is equal to half EI theta B is 0.5 ei theta b minus 20. So now this is the first equation. Okay. Next, calculate the second slope deflection equation. So second slope deflection is Mba. So Mba is nothing but 2ei by L. Okay. Now this time you're writing B first. Okay. So B first means write this formula as it is. So theta A, because always the first term. So go in the sequence only. So theta A would be 0. Okay. Plus now theta B you're writing it first here. So whichever is the first joint, that you should multiply with 2. So theta A plus 2 times theta B. Again, it goes with the formula that is minus 3 delta by L. Close the bracket. Plus Mfba. Okay, so again now Mfba we have already calculated. So Mfba is 20 kilonewton meter. So write it as 20 kilonewton. Okay. So now let's substitute. So it is 2ei by L, that is 4. Theta A is 0. Why theta is 0? Because end A, okay, fixed support. So fixed support, there is absolutely no chance of rotation. Okay. So that's why it is 0. So we'll equate this to 0. Again, there is no settlement happening, no sinking of the support happening. So here also it becomes 0. So the only term left here is 2 times theta b. Okay, then substitute this Mfba. So Mfba we have already calculated. So Mfba is plus 20. So we'll substitute it here. Okay, so now we are left with, so Mba is equal to, so 2 2s are 4. Okay, which cancels out. So we are left with ei theta b plus 20. So now this is the second equation. Okay. Similarly, now we'll calculate the next span. So we have calculated AB, BA. Similarly, next we have calculated BC, CB. Okay. So now MBC is 2EI. Okay, now MBC is equal to, again write the formula, 2EI by L. So B is the first term. So first term will have 2 in it. So 2EI by L, 2 times theta B plus theta C minus 3 delta by L. Okay. Plus MFBC. Now we'll take the next. So MFBC also we have calculated here. Okay. So now MBC is equal to 2E. Now BC is a span where you have I as 2 times I. So that's why 2E, instead of I, I'll write 2I. This is one thing you have to be very careful when you start solving this, because you have to always check out the I values for each span. So it is now 2I becomes 2I divided by 6. Okay, length is 6. Okay, now see here, in span theta B and theta C again happens to be a fixed support. Again, fixed support, rotation is 0. So because the rotation is 0 here, we will equate this theta C as 0. Again, there is no sinking of the support. So again, 3 delta by L becomes 0. So we are left with only theta B. So once you substitute all the values, so MFBC is minus 60. So you should again be careful when you're checking the signs, when taking the signs, because the anti-clockwise movement, so minus sign is dominant here, so minus 60. So now MBC is equal to, substitute this value. So it is 4 by 6. Okay. So again, if you multiply this, so it is 2 2s are 4, 4 2s are 8. Okay. So it is 8 by 6. So 8 by 6, when you eventually cancel the, so it becomes 4 by 3 EI theta B minus 60. Okay. So now MBC is equal to, so 4 by 3 is 1.33 EI theta B minus 60. Okay. So now this is the third equation. So the next equation is same thing, MCB this time. Okay. So MCB is, again, C is the first term. So it is 2EI by L. First always write the formula, 2EI by L. So first term is C here. So what I'll do here, as usual, I'll write this in the sequence only, theta B plus, because the C term is first here, so I'll multiply 2. So it is 2 times theta C plus, now I already know that delta is 0 here. So 3 delta by L square. It is 3 delta by L square. I've taken it 0 only here. Okay. Plus Okay, MFCB. MFCB is already calculated. MFCB is plus 60. Okay, so we'll write it as plus 60. So again, multiply this. Again, theta c is 0 because it is fixed support. So 2 EI by L into theta b. So it is 4 by 6 plus 60. So 4 by 6 is nothing but point. Always keep it in points. So it is easy to solve. So it is 0.67 EI theta b plus 60. Alright. So we've calculated the first thing, we have calculated the fixed end moments. The second equation, second step was to calculate the slope deflection equations and conclude and make equations for every joints. And the third the third step is joint equilibrium equations. Okay. Now joint equilibrium equations are nothing but we have to consider a joint in such a way that it connects all the members. Now if you consider joint A, so joint A connects only A to B. Okay. Likewise, joint C connects only C to B. But we are more interested to check the joint wherein both the members are connected at the joint and they are said to be in equilibrium. Okay, now you can see here joint B. So if you consider this joint B, to the left side it connects BA, to the right side it connects BC. Okay, so I will consider this joint. So I'll write it as joint equilibrium equation and I'm finding the moment about B. Okay, joint equilibrium equations. So consider joint B. Now joint B, it is connecting, joint B is connected from B to A and B to C. Okay, so that's what I'm writing here. So it is now consider joint B. So it's connecting BA also, BC also. So now I'll write it as MBA. Okay, you can see here B, it starts from B to A. So I'll write MBA plus MBC is equal to 0. When you're writing this, you should be very careful. And one more thing, BA is not equal as AB because there is a difference in the sign. Similarly, BC is not same as CB. Okay, so you have to choose the and write it very clearly. You have to write the moments very clearly. So in that case now, MBA plus MBC, okay, is equal to 0. So we'll choose MBA equation and MBC equation. So it would be equation 2 and equation 3. Okay, so MBA, the equation is theta B EI plus 20 and BC is 1.33 EI, same thing, 1.33 EI theta B minus 60 is equal to 0. So now solve this equation. Okay, so theta B EI, so solve this, solve only. So this is 1 theta B, this is 1 theta B. So when you add this, so it is 2.33 EI theta B and this is 20 minus 60 is minus 40 is equal to 0. So EI theta B, keep it as it is, and 40 when it goes this side becomes plus 40 divided by 2.33. So 40 divided by 2.33 would give you 17.16. See, now that we don't know the EI value, right? So keep it in terms of EI theta B. So wherever there is EI theta B, in that place, I'm going to substitute it with this answer. Okay. So now, so EI theta is 17.16. So now this value will substitute in all the equations which we have already written here. Here, first is MA. See here, MA, it has EI theta B in it. So we'll substitute EI theta B with 17.16. Okay, so we'll find the moment. So this is the moment about AB. So first equation, MAB is 0.5 EI theta B minus 20. So I'll substitute here. MAB is equal to 0.5. So EI theta B is 17.616 minus 20 is equal to, okay, solve this. First multiply this and then deduct with this, subtract from this. So you'll get this answer. Now this is a moment, so moment will be in terms of kilonewton meter. So it is kilonewton meter. Similarly, next BA. Okay, so MBA, again we have the equation here. This is the equation. So EI theta B, instead of this EI theta B, substitute it with 17.16. So we have done that here, plus 20. So it is, when you solve this, it is 37.16. Okay, the third equation is MBC. So MBC is 1.33. Again, in place of EI theta B, substitute with 17.16 and minus 60. So that would be, okay, minus 60 is 37.17. And finally, MCB is 0.67. Again, EI theta B, substitute with 17.16 plus 60. Okay, so now this is 71.49. Okay, now the final check whether whatever you have done is right or wrong, what you have to do is you have to choose the joint where there is, you have chosen the equilibrium equations. Now that's here, MBA and MBC. So initially what you have told, in considering joint B, MBA plus MBC, when you add this, both of these moments, you should get 0. So check this now. MBA is 37.16, so it's positive. So MBC is minus 37.17. Okay, so when you add this, it should be 0. So always MBA should be equal and opposite to that of MBC. Only then whatever you have solved, this would be right. Okay. All right. Till here, it is about finding. Till here, it is all about finding the moments. Now, in the given question, they've asked you to find slope deflection method. Find using the slope deflection method, draw bending moment and shear force. You have to also find out bending moment and shear force. And this is more or less like what you have done in SOM. Okay. So what we'll do here is, again, as usual, we have we'll treat the beam separately. We'll treat both the beams separately, and then we'll apply load and find out all the reactions. Okay, so let us start with the first one. See, all these equations what you have found, will be putting it here, we'll be using it. I've showed it with the red pen, red mark. Okay, now see here, the first in span AB, I've taken AB with a point load at the center. So this is all given, right? So RA is nothing but the reaction at A. Similarly, at B, I'll write this as RB1. And there is a reason why I put it with the suffix 1 is because at B, there are two spans. Okay, one is BA also. At the same time, there is BC also. So to make things simple, so RB, I'll be splitting into RB1 and RB2. That is with respect to its span AB and BC. Okay, all right. So first span is AB. So in AB span, there is a reaction RA and RB. Okay, so because it's a fixed support, to make things simple, we are just excluding the horizontal movement, because horizontal movement is very negligible. We are more interested in the vertical movement. So always, whether it is fixed support or simply support, we'll always consider only the reactions here. Okay, that is vertical reactions. All right, so there is a vertical load acting downward and there is reaction acting upward. Okay, now what I've showed with this red mark is what I've found out here. Now you can see here MAB. So MAB is nothing but a fixed moment, okay, at AB. So it is minus 11.42. So minus sign indicates at A there should be a anti-clockwise movement. So I've shown it anti-clockwise. So minus sign is taken care by the anti-clockwise movement, and then the magnitude is 11.42. Similarly, in BA, now you can see BA. So in BA, it is plus 37. So plus sign indicates I have to show the moment as positive. So it is plus. Plus I've shown clockwise. So minus sign I've shown anti-clockwise. Plus sign I've shown clockwise. Okay. Similarly, in span BC. So in span BC, again, because B has two, we have split the components, we have split the reactions. So in BC, I'll name this as RB2, and this is at C, it is RC. Okay, again, C is a fixed support. Because it's a fixed support, I'll still be treating it as a vertical, only one vertical reaction. The horizontal movement is neglected. Okay, so now BC, then check this out. BC, again BC, the magnitude of the moment is minus. So minus means I've shown this as anti-clockwise, followed by the magnitude 37.17. Again 1617, it's after decimal point, you can take the same as it is. Then RC, okay, next at C it would be C to B. So C to B, okay, the answer is moment is positive. Positive, I've shown it as clockwise. Okay, so you can see here 20 kilometers is trying to push the beam downward. To stop this from B, there is a movement which is trying to push it up. At C, there is also a clockwise movement which is trying to push the beam up and keep it in equilibrium. Okay, having known these moments, now these are the spans which we'll be using later. Okay, so first I'll find, ultimately we have to find the reactions RA, RB1, RB2 and RC. So all these reactions you have to find. To find out these reactions, okay, first I'll consider span AB. First span AB. In span AB, I'll keep the moment about B as 0. Okay, always take the, try to keep the farther moment 0 first. So in span AB, so B is a moment, B is a support which is far from A. So I'll keep this moment at B as 0. Of course, you can do vice versa also, but to make things simple, so if you keep moment at B as 0, we'll get RA. That's why I'm keeping moment at B as 0. So MB is 0. Okay, as usual, go on solving this now. So moment about B is equal to 0. So left side, clockwise is positive, anti-clockwise is negative. Okay, so clockwise, RA is going clockwise. So clockwise is RA into distance 4. Next, there is a moment which is anti-clockwise. So anti-clockwise minus 11.42. Then this 40, it is also going anti-clockwise. So anti-clockwise is negative. So it's minus. So this is 40 into perpendicular distance. So distance is 2. Okay, half of this distance. Then we are taking moment about B is 0, but this moment is acting at a farther distance from B, so we have to consider this moment. So now it would be, this is going clockwise, so clockwise it is plus 37.16. So eventually when you solve this, you'll get the reaction RA. Okay, that's why I've taken moment about B as 0. Okay, so RA I've got. Now next, find the moment at so we've calculated RA. Now we'll calculate RB1. Again, to calculate RB1, it is moment about A is equal to 0. You take moment about A is equal to 0. So as usual, go on finding this. So RB1 into perpendicular distance 4. Again, RB1 is going in the anti-clockwise direction. Okay, so RB1. So right side anti-clockwise is positive, clockwise is negative. You have to remember the sign conventions. Then minus, okay, 37. Okay, so 37 is going clockwise. So right side anti-clockwise positive, clockwise negative. So minus 37. Next, 40, it is going anti-clockwise. So clockwise. So it is plus 40. We're finding moment today. Okay, so 40 is going in clockwise. So right side again clockwise is negative. So minus 40 into 2. Again this is going anti-clockwise. So minus plus 11.42. Okay, after you solve this, you'll get RB1. The same thing should be repeated for span BC. Span BC, again moment about B is equal to 0, RC into this distance 6. Then this is clockwise, so it is plus, and 20 into this distance. So it is now 20 into 6 into 6 by 2. Okay, 20. You can see here. It is 20 into 6 into 6 by 2. Then again, this is clockwise. So clockwise plus 71.49. Okay, you'll get RB2. RB2, and similarly calculate moment about B is 0, we'll get RC. Okay, moment about B is equal to 0, so it is RC into this distance, then this distance to 20 into this, and finally 37. Okay, once you find out all of this, next is you have to only add up, sum up. So again, once again, redraw the equation, redraw this complete diagram. Okay, mark all the salient points. So A, B and C. So again, when you're drawing this diagram, keep A as simply support only, C also as simply support. All right, mark the loading conditions here. So one is 40, next is there is a UDL. Then most important is when you add of these reactions, okay, when you mark these reactions here, RA, whatever you've got, RA, right, 13.56, okay, it is upward, 13.56, then RB. Now RB is a cumulative value of RB1 and RB2. Okay, so when you add this, it is 80.72. Similarly, RC is 65.72. Okay, okay, then now next step is very, very important. Okay, we have already done this to find shear force and bending moment in SOM. Okay, now let us start. Just draw a straight vertical lines for every point, for every ABC point and below the loading also. Okay, so at A, start the so this is like a zero line shear force. Okay, you have to use the cal C, and then upward, all the upward forces are positive, downward forces are negative. All right, so now start at point A. So RA is going upward, so upward means plus, so type 13.56 in the cal C. Okay, so it is plus. Now between A to this loading 40 kilonewton, there is no load, so draw a straight line. So in the cal C, it is now 13.56. So 13.56, so it is plus value. Continue with the same 13.56. Then 40 kilonewton is acting downward. So downward means negative. So minus. So in the cal C now it is 13.56 minus 40. So minus 40 would be, again in the cal C it would be minus 20.44. So draw it in the negative sign. Again, from 40 to B, there is no load. Because there is no load, draw a straight line. Okay, now you're at this point. So at this point, it is now in the cal C it is minus 20.44 and RB is 80 points. So it is plus, it is going upward. So it is plus 80.72. So this is plus 80.72 would be now plus 54.28. So show it in the plus positive side. So it is plus 54.28. Okay. Now there is a UDL. So it is in the cal C it is now 54.28. So because it's a UDL, it is trying to act downward. So it is 54.28 plus 20 into 6 is to multiply load into the complete length. So it is 20 into 6. Okay, so straight away it goes from plus, it changes to minus. So you have to draw this line like this, from plus to minus. So it is now minus 65.72. So you're at this point. So minus 65.72, and there is the RC which is acting upward. So it is plus 65.72. So you have to draw this line. So plus and minus. So it cancels, and now you have reached the zero line. This is how you draw the shear force diagram. Okay, next is the bending moment. Again, bending moment is very simple. So what you have to do here is, first you have to draw only the free bending moment. Okay, so free bending moment is nothing but what you have already studied, that is for a point load the bending moment is WL by 4, and for the UDL it is WL square by 8. Okay, so first let us draw, again below the line just mark this vertical line. Okay, so at A is the simply support, bending moment at A is 0, B simply support, C at B it is 0, similarly at C it is 0. All right, okay, now at A there is a loading here, 40 kilonewton load. So 40 kilonewton load, so bending moment, free bending moment. So what I'm going to draw here, only the triangle first. triangle and a parabola. So first at A it is 0, okay, below the load, so it is WL by 4, okay, at this point WL by 4, substitute the value, so it is 40 into 4 divided by 4, so it is 40 kilonewton meter. Mark this. Then come back to B, it is 0. Next, from B we know that again this is a simply support beam with a UDL. So UDL, it is nothing but WL square by 8. Okay, free bending moment is WL square by 8. So W we already know 20 into 6 square divided by 8. So it is 90 kilonewton. So mark this point in such a way that it is should be slightly higher than 40. So we'll mark this. Then draw the parabola. The next thing is, okay, we have got the fixed end moments. So fixed end moments are nothing but what you have found out here. AB. So AB will be acting exactly on A. It is negative. Always draw the fixed end moments in the upper side only. Okay, now see here. It is 11.42. At B it is plus and minus 37, and at C it is 71. So always these you have to show above the points only, like this, exactly above the joints. So at A it is 11.42, at B it is 37.16, and at C it is 71.42. You have to mark this. So then join this line, next this, and finally 71. So you should draw in such a way that at least this should be to some certain scale, 90, 40, 11, 37 and 71.42. Then join this line. Okay, once you join this line, you have to just highlight these. So this, all this indicates, okay, they don't overlap. You can see here, they don't overlap on the free bending moment. Okay, this is completely free. This is also free. Okay, you have to show this. The minus sign indicates that is those are negative bending moments. Plus sign, okay, see, which is lies above this line, okay, indicates positive bending moment. So there are two types of bending moment here. One is negative bending moment, which occurs at the joints, and there is a positive bending moment which occurs below the load. Okay, all right, so with this we'll wind up this, and this completes the first module, first type of problem. Okay, the next type of problems are more or less the same but with a more spans. Okay, that's it for today. Thank you.